quite often. They're all the same thing. They're just something that helps to process a command and control its life cycle and persistence and all that good stuff. So, we'll just call this invoker. All right. So we're going to make this a public class invoker. And if you've seen the other design patterns, one of the bedrock components of any design pattern is an abstraction, and an abstraction is going to be what you use to funnel or access the underlying behavior, or to bridge it, as with the bridge pattern. But in our case, for the invoker, we want it to do a, let's say, public void execute. And typically, you'll see that the commands will return like a console output or something like that. We're going to have the execute return a response. But we just wanted to create it first and have it there so that if we're inside of our program, we can say var invoker equals new invoker. Cool. So we've created it, and we're going to go ahead and commit that. Okay, so that's done. Moving very quickly. It's a great pattern because it's so skeletal. And to get it up and running very quickly only requires the bare minimum amount of classes and code. So I'm going to do the request object and response object as one step because they definitely go in, they play very nicely together. So inside of my invoker class, and this is where I like to have this generic pattern, and it differs something slightly from what you'll see in the typical Gang of 4 stuff. I want to create a request class. So I'm going to add a new, item. And I'm going to call it request. So, the request is what we'll be passing to the invoker. And then the invoker is going to decide what to do with that. So all I want in the request is a public command type. It'll be a property. And this is where I want to make it really, really generic. I'm just going to say that I want the public data, just be an object. And then I'm going to carry with it a type. This is about as generic as you're going to be able to get because everything in C# is an object. And you're probably more used to seeing the alias there of just object. So if our abstractions are a way for us to say the lowest common denominator is X, so the lowest common denominator in this case is request, and as long as you package your data in a request, it will be able to work with the entire system. So request is one of our lowest common denominators here. For C#, the object is that. Everything is an object. So push come to shove, you can always do object-based operations. So for any object that you create, any class you can create, you can always do a toString, for example, because everything in C# is an object. So except for primitive types. But they still are, but we'll ignore that for a second. Okay. So, I'm also going to create my response. Alright, so if our request was our contract for what goes in, then our response is our opportunity to say, no matter what the system does, I want it to return something that I can digest uniformly. So in this case, all I'm going to do is say string, and we'll just say message, because that's something that we can output to the command line very easily. Okay, let's go back over to our invoker for a second. And so now we can say that the invoker is going to take in a request and return back a response. Okay. And we will ignore that for a second. Alright. Well, just so we're not checking in broken code, we will say throw new not implemented exception. Okay, back to the kata. Done and done. Alright, so now we want to create an iCommand abstraction that specifies a method that takes in a request and returns a response. So let's just create a new class. It's not going to matter what it is. So we're just going to call it foo.whatevers. So we have that there. Now I'm going to create our iCommand. Make this an interface. And the only thing that I need this to say is there's going to be a method called execute that returns a response and takes in a request. Then back inside of our foo class, we're going to say I want to reference that. Resharper is going to be nice and tell me that I'm missing a member. I'll let it go ahead and implement that. And then, now, because I've got an object inside of request, I know what that is. And to keep things simple, I'm just going to take advantage of that knowledge. Typically, you would want to, you're either going to have a system for finding out what that type is, invoking it based on the type that's been supplied, or restrict what it can be inside of your request object. So all we're going to do is we're going to say that var data is equal to, we're going to cast the data to a string. And then we're going to manipulate it. And so we're going to say data is equal to, we should say data plus. This has been processed. my foo. And then we return data. Oops. Here we go. Oops. Return new response. We're going to use an object initializer to say message is equal to data. Okay. So, super simple. Couple shortcuts, but we just want to illustrate what the command pattern is supposed to be doing. So, foo, and it could have anything else it wants in here. It could have properties and fields and all kinds of things. But all we care about is that it takes a request and returns a response. And just for the nicety of it, we're going to go ahead and operate on that request a little bit. And hang on real quick, I'm going to turn on the light because I think it's getting dark in here faster than I would have thought. Hang on. Alright, that seems a little bit better. Okay, so back to our kata. So we made that command abstraction, and we can place this on any class we already have, which is something I didn't like about some of the examples I saw, where you really had to conform rigidly to their pattern. You couldn't apply this to legacy code or to things in different domains. We want to be able to do that. We want to be able to just go ahead and throw an iCommand on, throw this method in, and be able to call it. So let's go ahead and check that, or commit that to GitHub. I keep saying check in because at work we use TFS and it's source control mess, and then at home I use Git. Semantics. All right. So, and if you're playing along at home, when this video goes up, you'll be able to browse the commits, and you'll be able to see the code, and hopefully it'll be properly labeled with what step they're at, and you can pause and analyze and do whatever, rewind, as you like. So if I came back to command pattern, I got 7 commits. And you can see that they're all initial commit, create simple UI, create command types, create invoker. And if you went in and browse the repository here, you'd only see the code that was at that part of the video. Okay. And hopefully in the future I will redo just the kata part of the video, redo the kata itself, and so that way it's not attached to this hour-long thing. It'll just be like a 15-minute with source code kind of example. All right, so back to the kata. So I created my command abstraction, and I did create the concrete command. I might fine-tune these steps, but let's go ahead and wire this up. So I've got an invoker, and I like it. And if I do invoker dot execute, it's expecting a request. So I want to do var request is equal to new request, instantialize with an object and initializer. Command type is equal to command types. We'll just say create. And our data is going to be var.